Welcome to this webinar, everybody. The webinar is live transformation, shifting COBOL to compute to Azure. I am Jorge Morlet, Field Sales Director with CloudFrame. Okay, so first of all, truly appreciate your participation here. Having you on this webinar is very important to us. What I'm gonna do here is really run a live transformation and explain you how a process of shifting some COBOL computing to Azure works. It's a task that we've worked for a long time in order to make it as simple as possible. It is a process that requires really deep knowledge, but we have automated everything that is possible to be automated in order to reduce the need of, or the possibility of errors. So risk is one of the most important things that we're taking control here, but also helping you during the process of the transformation. What we're doing is providing solutions that will allow customers to move COBOL compute into Azure very quickly and very easily. We're with the goal to accelerate the time to achieve your results. Also, all difficulties that you will find if you're trying to shift computing from mainframe to other platforms, we're taking control of that. But most importantly is reducing the costs and the utilization of your MSUs and MIPS without any risk. And I'm going to swap out of the presentation for a second because I want to show you this information that we have that talks a little bit about the savings that you will eventually get from this model of shifting compute into Azure. There's this information that we have on our CloudFrame webpage, which speaks about every possible pricing model that you have. It's analyzed here. We explain how each one is going to be positively impacted if you move your computing or your compute power into Azure. At the very end of this this article, there's also links to deeper information or further articles, even a book that Craig Mullins has written based on the CloudFrame technology. But also at the very bottom, there's a link that will take you through the business calculator. I love this one because it's very simple. You just provide a few information. We reduce this to the minimum possible number of questions. I think it's 6 questions. If you provide that information here, you will get a calculation on the impact on your savings. And this is very powerful. The accuracy is really, really good. I'd say if you compare this to an analysis that somebody can do for you and take 6 months with, consultants and asking for questions and all that kind of investigation, probably the accuracy is going to vary no more than minus plus 5%. So I strongly recommend you to go in here, check what the projection of savings could be in your specific scenario. Okay, so with that, let me go back and continue. There's a poll that has been just popped out here. If you want to answer, that'll be awesome. Please, appreciate that. And let me continue with the presentation. Okay. So first, explain what is CloudFrame, what do we do, how we're different in the market, the products we have, and then I'll go deeper in what we call the incremental journey of mainframe transformation. Okay. So the first thing we have is we've created 2 solutions that will allow the customer to make a decision on what is the pace and how is that they want to do the mainframe transformation. Okay, we're focusing on the COBOL applications. That's very important. Okay, we have 2 solutions. The first one we call Relocate, which is meant to help reducing costs within the mainframe. And I'll talk deeper about this solution because this is what I'm going to demonstrate basically. And then we have the second solution, which is Renovate, that basically transforms COBOL into cloud native Java. The first one does a cross-compiling process, which means you have your COBOL, but you convert that internally into Java and you execute as Java. As you execute your COBOL programs as Java, what you really are doing is offloading the GPPs, the expensive CPUs, and running the Java in the less expensive or practically inexpensive SIP CPUs. That's going to create efficiencies, and that is going to give you the room to negotiate some costs, benefits, and then you will be able to invest into create the infrastructure and the architecture that you will need to eventually go off of the mainframe and do a real transformation. Renovate is the one that is going to help you transform that code into a cloud native Java. The quality and the maintainability of our code is unique. We really automate the entire process. We generate specific classes that they are going along with the standard patterns for Java. We use the standard frameworks as well. We're making sure that this is a really easy to understand and maintainable code that any Java developer without any knowledge on COBOL can actually take and maintain. Okay, so we are working a lot. We've worked a lot already on the high quality, cost reductions, and very fast results. That's also a thing that we've been working a lot on because we want Relocate particularly to be something that can be installed in a matter of minutes. And I'll explain that process as well. Okay. So our vision in order to help customers, and this is optional, but this is how we propose this, and this is how we've seen customers of ours doing it. It's do an incremental approach. The incremental approach starts by shifting the logic, moving your compute from the mainframe to a less expensive architecture. In this case, Azure. Azure is very powerful, it's very simple to implement, and it's very easy to eventually, if needed, roll back. And I explained that process of rolling back very easily. So you are running already Java within the mainframe, and you know that it's a reliable operation. You know that you're getting the functional equivalency because you can compare the results. Okay. Then as you are getting these savings, you can start defining your strategy to shift, your tools and solutions that you use to control your operations, like schedulers, triggerers, all that kind of tools that helps you to control that operation. You can define a strategy in parallel. Then shift the data. You can also decide how do you want to move your databases, how do you want to move your or work with your copybooks and your BSAM files, your QSAM files, all of that type of information. You can decide how you're going to run a migration. And then when you have everything ready, you can go to the target state. Target state is you already created your architecture, your infrastructure, your everything you need to basically land your Java and make it run in a completely independent cloud environment or on-prem environment, but non-mainframe. Okay, so in parallel, you can also work into define data views. There's many strategies that we can help you there with. Okay. I'm gonna start running the demo, but before I do this, let me explain a little bit about the architecture of Relocate and how the installation process works, because you will see this running, but there's something that happened before, right? And I don't like, just to tell the part of the story. So I'll tell you the entire story. Let me jump a little bit into this other slide. Okay. So going again into Relocate explanation, it is incremental. You can move workloads to the SIP CPUs or a cloud platform by just defining very granularly to a level of the program or a group of programs or an entire application. Implementation is very fast, and I'll explain that in a minute. There's no risk or very low risk because in case you have any problems, you can roll back by just changing a couple of lines into your JCL. Okay. We keep what we call the backward compatibility at 2 levels. The level of the COBOL programming. What we do is we catch the COBOL program every time it is changed, and we migrate that and convert that into Java. So even at in the testing process of the software development lifecycle, you are already running as Java. You're testing the Java already in case you change anything to your COBOL. So you keep developing on COBOL. Your developers, they don't know, but they are actually running Java. Okay, that's at the programming level, and then we also keep backward compatibility at the data level, because everything that you're running on your SIP CPUs as Java is accessing the data as if they were just running within the mainframe, or if you run in the Azure compute as well. It runs the same. You're accessing the same data. You don't need to change. We've created the libraries that control that access to the data into VSAM, QSAM, or DB2 files without any problem. Okay, so let me go a little bit into the left side of this slide and explain very quickly the architecture. Basically, you'll have the mainframe connected to the cloud. Okay, the way to connect this is by using two CloudFrame components. The first one is a group of ISPF panels that you need to install in the mainframe using a standard SMPE process for installation. And then the second part, the second component, it's the CloudFrame server, the one that will basically migrate and run your Java. Okay, and let me go and explain to you how to run the installation of both. So one thing I'd like to share with you is first the installation process of the SMPE is documented on the CloudFrame Knowledge Center. So if you just go and do SMPE, everything is properly documented in the installation guide that we provide for this. So it's a very simple process. We have two options, by the way. You can install the SMPE, which needs to be done by a system programmer, but you can install the non-SMPE version, which can be just installed by the application owner. It's a very simple process. Actually, it takes about an hour or an hour and a half, depending on the experience of the person doing the installation, but everything is properly documented here. Now, let me go and explain the installation process of the other part, which is the CloudFrame, the cloud side. Okay, so the CloudFrame server. Okay, once you have the installation of the panels and the agent on the CloudFrame mainframe side, you need to run an installation of the CloudFrame server. We already are in the marketplace. I'm using an external user, and you can go and click on the COBOL Batch to Azure solution that we have on the marketplace in Azure. Okay, you have the option to start free, and then you can create a new environment. This environment is going to run the entire deployment for you. And let me create a new resource group, which I'm going to call, let's call this Batch to Azure. Okay. Click OK in this one. And this is very important to mention. You can actually define the power and the size that you want to use in the servers that you are going to deploy for your instance to run. You can, for example, change the type of size. If you know how much compute you're going to need to this specific operation or operations that you want to offload, you can go here and check, any server you want to use, have them predefined and all that. One of the rules that you can also check is if you want this to be trial or production, the monitoring is actually controlled. For trial, we are not running monitoring. For production, we are running monitoring automatically. You can also set these servers as ephemeral. So you can not only change the size, but also decide that once this operation is done, just copy the files back into the mainframe and, kill these servers so we don't spend much money in the cloud environment as well, and we make this efficient. Another thing that you can do is give alerts to your own user. I'm going to put mine here, and then you have to give a name to your application. So I'm going to call this Batch to Azure. Okay. These are the only parameters that you need to set in order to create your entire environment. Okay. You, after a small validation, you can agree and run the generation of the deployment. This deployment process will take about 20-30 minutes. So I'm not going to use this environment. I prepared another environment ahead, and let me go into that environment. the environment is going to be something like this. This is the first screen that you will have to log in, okay, and into the CloudFrame server. So going back to my diagram, this is the right side of the picture in the architecture. This is the CloudFrame server that is going to be actually connected to the mainframe, but running into cloud environment as a graphical user interface environment, which is this one. So if I click here, I just log in and I authenticate. The first thing I'll need to do is to configure some connectivity to the mainframe. This is my instance. This is the port. There's an IP address over there that I need to use in order to connect to the mainframe. So once I have connection to the mainframe, next thing I need to do is to configure some migration parameters to make sure that the migration is going to succeed. There's some standards. We can explain that later, but this is the way the migration is going to run. And then I'm basically ready to run a migration. As you can see right now, there's no programs into my environment. So I'll start running the demo for you right now, okay? And obviously the demo has basically a sequence, which I'll explain first. So it all starts in the mainframe. You have in your mainframe, your application that has basically three parts: the compute, the output, and the original data source, and everything happens in the mainframe. Okay, and let me show you that. Okay, if I go out of here, there's this application that we have for demos, that is the trading application. If I check into my members here, you see that I have one program that is called TRDPB006. And if I review this one, you'll see that this is the program. Standard program, identification division, environment division, and data division, and of course, the procedure division. I go to the procedure division, you'll see there is a very simple logic, which is basically opening a cursor, and then it's executing some queries, and then after that, it's writing that into an output file and closing everything. The subroutines initialized and the opener cursor, everything is there. So a very simple program. I just went ahead and compiled this program. The compilation result is located in my listing, which is this dataset here. And I also have a couple of JCLs that I use to execute my processes, okay? So this is my JCL, and I have these two JCLs. The first JCL, it does have the execution of the initial state, which is the one that I just described to you here in my slide. So everything happens in the mainframe. I'm going to run the program with a JCL that is going to use the compute and the tables and the output. Everything is going to happen within the mainframe. Let me go ahead and, let me first check if I cleaned everything. No, let me just go ahead and clean all the previous executions, because I want to make this very clear to everybody that this is running from scratch, okay? So go to my JCL, view it. So this is going to run the trading demo in COBOL and DB2. It's going to generate my output in this file. So let me edit my output file, use DSE here with my F4. And gonna, I tried to do res. I'm gonna clean the content of this file, everything, just to make sure that I'm creating also everything from scratch here. And as I go back to my JCL, you see that I'm calling in this card is going to be my compiler listing, my program that I'm going to execute. And so with that, I can just execute the as is situation, right? So runs, no errors. Let me swap to my log, CDJS output. I'll show it this way. So what happened on my execution? Well, if I find my consumption of my CPU, I see that I spent 0.09 seconds by executing this report. Maybe not much, but if you have big volume, that could be very, very expensive, right? So if I swap back you'll see that the report has been generated. Let me go to F4 again. My report is there. If I go to the bottom, you'll see that I have 11,000 lines of report there. So that is the original as-C situation. Everything runs in the mainframe as usual, okay? Then what I'll do is run a migration of this program. And when I migrate, I'm going to tell that I want this program to be executed in Java, but in the Azure environment, okay? So this is what I did. I run the compute, the database, and the output in the mainframe. And now I'll shift my logic to the Azure environment. To shift the logic, I'll use the CloudFrame panel. And the CloudFrame panel will take me to this environment. In this one, I can choose running a migration of just one program or a group of programs, as I mentioned. I'm doing this manually because I want to show this in my demo. This can also be automated. If you have already solutions to automate your software development lifecycle, like Endeavor or Change Management or anything like that, we can actually automate that part of the process. I'm doing this manually on purpose. So my trading listing is there. My DVRMs are there. Everything is ready. This is going to be a batch process. I just hit enter. And then, oh, what program do you want to migrate? I want to migrate this guy. Just select this, give my collection name, hit enter. And then when I get out of this environment, what I get is a JCL that will actually run the migration of the program. We'll convert the COBOL into Java. So this is where the magic happens. As I submit this guy, it's gonna run the process in a couple of, not even a minute, I think. And there you go, the process is done. And as you remember on the architecture diagram, these panels are connected to my CF server in the graphical user interface. And let's check if that's true. If that's true, I should be getting into my operational log some information about the conversion, the migration that I just launched. This is a few hours difference, but this is the migration that I just launched. I asked for this program to be migrated. It actually went ahead and run the entire migration process, which is understanding that this is a valid compiler listing and generated some Java classes that they are hosted into my Azure environment. My Azure environment now does have all these classes which they're ready to run. Okay. If I go back to my programs, I can check on the list of my programs that now I have a program. I can fetch this program locally to see what are the conditions of that. And I see that it has an output file that is going to run in the mainframe. Okay. So if I go again and I use a different JCL to execute my new program, this is going to be the one. And let me show you this new JCL. It is important to mention this JCL is going to run the trading demo, but this is going to be running in Azure. Okay. The output is going to be going to this file. So let me also clean this file for you. Okay, save it and go back to my JCL. Very important to mention, I made some changes to this JCL compared to the other one. I added these libraries. These are the CloudFrame libraries that will control the execution in Azure. Okay, you don't need the COBOL library anymore. If you want to roll out, the only thing you need to do is comment these previous 3 lines and bring this line as it was and rerun your process. That is your rollout. It's very simple. Okay. Now, if I submit this process, what is it going to happen? The compute is going to run in the Azure environment. Let's see if that's true. Okay. So let me swap to see my executions. It is running right now. It's done. No errors. Okay. Let's see my execution results. Select this guy. If I find my CPU consumption, my GPP went from 0.09 to 0.02. So I offloaded about 75, 80% of this compute into an Azure environment already without doing any change to my code. Okay. So this is part of the process. I can actually go beyond, keep moving forward on things that the incremental process. So this is what I just did. I swapped the compute to the Azure environment. I run the process, and it generated my report. Oh, by the way, let's check the report is there, right? So let me swap here and go into this guy and bring it here, and you see that the report is there. And if I go to the bottom, it's the same 11,000 lines of a report. Okay, so yes, my report is there. Also, another thing that I can do is start shifting the data. What if I use the same Azure environment, my same cloud, but this time, instead of keeping the output files in the mainframe, in any case, I need to give these to other external customers, right? My end customers, they need to have this file. Why don't I just generate this output already in a cloud environment to give it easier to the customers? Yeah, let's do that. So I can go here. I know that I have already my programs there. Let me go to my programs and list my program here, fetch that local copy, and then go to the files and tell, you know what, I want the output to run into an Azure Blob Storage. Why not, right? I have it is already there. So let's just submit this. Oh, I need to tell the name of the output, right? And let me also change. I want this to be, visually understandable. So I want the lines to be separated. Okay, then let's just submit this guy. And once this is done, I can go and remigrate the program. Okay, license. Oh, I clicked the wrong button. So programs. Let me go check again, because I don't know if I submitted this properly. Fetch local copy, and then check on the files. Yeah, it is already there. This guy. Lines, yes, submit. Yes. Okay. And then I now need to go to my programs and remigrate the listings. I can pick and choose the one that I work with. I'm remigrated because this time my program is gonna generate the output into the cloud, right? So I need to tell that this is a new migration, a new process, okay? I don't need to download nothing now. So my process is ready. How do I know that? Because I'm gonna run it again, okay? So let me first clean this all the way for you again, the output. I can just delete all the content of this file and then save it. And then I can just rerun this same JCL with the difference that these libraries, they know that now my output is not gonna go here, it's gonna go to another environment, right? So I don't even need to change that. I just need to submit this guy. If I submit it, and then I swap to my executions, let's go out here. Process is running, no errors. This is already run. So my second AC job execution is here. Let me check what happened there. So let me find my CPU consumption. It keeps going down and down, right? So from 0.02 to 0.01, so it's virtually nothing. I'm just using the GPPs just to, read some data over there. And so this is very powerful. The process keeps improving, okay? And let me go and see what happened to my file. I run this one and I did not generate data. Why? Because my data is being offloaded to the blob storage as I indicated here. My blob storage is going to be here. And let me just refresh this. And you see that the RepOp process report is generated here. If I click and I edit this file, you see that the content is being offloaded into the blob storage. If I go all the way to the bottom, that's 11,000 and something lines of report here. Okay, so this is the entire process of going to the point in which you can actually shift most of your data. If you want to continue, you want to shift also your database, you can then use the Renovate solution, which I described in a previous webinar. I think in October we recorded a webinar that explains exactly how the Renovate process works and how you work with maintainable Java. So I recommend you that if you want to see the end of this process, the continuation, go and see that video. But the end result is you have maintainable Java that can run in Azure very simply, very easily. And so you not only will have your outputs, but also all the data there. Just let me wrap up and see if David have any other questions. So to wrap up, this was the Relocate, the architecture and how it works. How this converts into money? Well, we have a customer success case. This customer. Sorry, go ahead, David.
Yeah, so go ahead, walk through. We'll see if we get questions here.
Yeah, we have this oil and gas producer company. They're very large, and they were using an MSP provider to run most of their operations, and they were having very high costs on those operations. What they did is they use our solution Relocate to basically offload the consumption of the GPPs. They are saving 47% in the MIPS utilization. They were able to go back and negotiate with their vendors the cost reductions, and now they're going beyond even for other applications. This is a very critical application they are working with, which is the futures trading. So that's the kind of code that we can basically manage and work with. This is not the only customer we have with very critical applications. There's many others, but this is, I think, very nice to talk about it because it was immediate savings. Okay. The Renovate, like I mentioned, there's another webinar in which I talk deeper about this thing, but I just like to talk a little bit about what is the end state or the target state of this process of the incremental proposal that we have. So this is it. You can create your design time in which you will be making the conversions, connect to the mainframe, automate the extraction process, and use the design time to do the migration and the generation of the code. And then you can take your code and deploy into your runtime in the end state and the end architecture that you will use. Very important, use a well-architected framework. Azure does have a lot of information to provide and how to configure that and manage it properly. But the most important thing is that we generate maintainable code. We separate business logic, data structures. We use the state-of-the-art Java patterns, and we are template-based. Since we are out to generating code, we have templates that they can eventually managed by the developers as well. And so the code that they generate is going to have already the frameworks and standards that they need. David, do we have any questions there?
We don't have any questions from the audience, but you can go ahead. These are some of the ones that typically come up when we get to the QA. So JCL and procs, obviously, if we look at batch COBOL systems, they're going to have those things, and we need to talk about.
Yes, let me talk about that. So as you saw, we don't need to change basically the JCL or the procs at all. The processes, the steps before and after the programs that we're working with, they can remain the same. All the outputs, the files, the temporary files and everything, no need to touch. Just the step in which we are converting the specific program, we need to add those libraries. So no transformation, no impact into the JCLs and procs, which is great. Okay. The deployment of the code, well, this is automatically done. Okay. And as you saw, developers, they don't even need to touch the Java code in case of Relocate. So that code is there, yes. Is it maintainable? Well, maybe by an expert Java guy, could be. But what we want is this to be maintained as COBOL. So every time a COBOL program is changed, we automatically can do the migration again and then redeploy. Okay. I think I mentioned already, can the Java code be maintained? Yes, it could, but we strongly recommend to just follow one strategy. You either maintaining COBOL or maintaining Java. Try not to do both. Okay. And I think I mentioned more than once, what about the data? Very important. In Relocate, we are not touching the data. We're keeping the data as is, and we're taking control with our libraries on how to manage the interaction in between the Java virtual machine that is running the Java and the data that is being accessed in the MVS file system.
Great. Well, George, we do have a couple of questions that have come in, and maybe you can address these. One
Perfect.
seems to be more of the customer's actual process, and then the other one seems to be more related to the technology. So we'll go to the technology one first. And it's asking a question about how we handle online applications using CICS.
Okay, that's a very good point. We can manage applications using CICS. Only I think it's important that when we approach the customers, what we do is we do an analysis, as we do with the costs, this analysis of costs the business case that I mentioned. We also do something similar with the status of the applications. And basically for Relocate, since the goal is to reduce costs, we try to attack the major offenders, the ones that consume the most of the GPPs. And over the night, the batch processes, those are very good candidates that we want to work with. Can we do kicks? Eventually, yes, but we strongly recommend let's go to the ones that they are going to give you more savings with less effort. And then you get the savings, and then let's do the migration in the final step of the kicks transactions using the Renovate solution. So that's our recommendation. And we also know, and I always hear this, yeah, but my installation is unique. You surely don't have this. You surely don't have that. Believe me, we have several customers in production. I'm running 3, 4, 5 POCs in parallel every day as a field engineer. My team, they're always finding new things. So far, we've addressed every possible scenario. And I'm pretty sure that if you contact us, we can review yours and make sure to give you the best possible advice on this journey.
Great. Thanks, George. And I just want to make sure that we point out that those are CICS transactions that are running in the background, and mainly we look at that as moving the actual application and something that would be performed in Renovate, not necessarily Relocate, which is the basis for shifting the COBOL compute to Azure here. So a little bit of a switch from the technology we're talking about now with Relocate, which is the basis for shifting the COBOL compute, into more of building the Java applications and addressing CICS and the transactional nature of that. That would be more of in the Renovate as we're producing Java applications. The next question was around the customer's actual processes and going into their DevOps environments, probably around functional and stress tests. Testing there. And it's the whole thing around, the customer's unique process of moving something that they've transformed, now proving that and moving it into production. There's a lot of testing that takes place. We actually want to make sure that the data precision is there, so the data is tested, the functionality is tested, and it's stress tested. So maybe you can talk a little bit about, how our teams support our customers doing that type of testing.
That's a great point. And that's also another thing that is a huge differentiator on Relocate. You don't need to change anything. Your testing process can remain the exact same. So stress testing, volume testing, QA testing, all the scenarios, steps, stages, and environments in which you're testing, they remain the exact same. The only thing is that you're running on Java. So if something is not giving you the desired result, you go back, you change and improve your COBOL, you remigrate, and then you start testing, but as Java. And this is very powerful because, like I mentioned, it's not going to give you any impact in your organization. It's not going to give you any impact in the way you're doing the things in that backward compatibility that we give you on the COBOL programming.
Mm-hmm. And I think, probably unique in the marketplace around offering a guarantee around functional and data equivalency.
Great point, David. If something is not giving you that equivalency, we will fix. We will give you a new version. Next time you run, you will get it. Guaranteed. Right. Correct.
Okay. And then we had another question from a different submitter. There are a couple of questions in here. One was about, how about DB2 workloads? Do they run in the zip or in the general CPU? And how about the JCL utilities and sort? JCL utilities like sort, I think we just talked about the changes in the job itself where we don't require any changes to that sort would potentially remain the same, but I'll let you address that. And then I can just go ahead and answer the question about DB2 workloads. Of course, they can be, where you are today are running in the zip. We need to configure that. That's an architectural question about how you're going to implement this, but we've worked with variations of that. So I think, DB2 and that workload obviously deployed to the zip is something that's very relevant to this type of processing. But maybe George, just expand on that and the utilities like sort.
Yeah, that's a great point. So in this scenario, we're shifting the compute to Azure. So the first thing that you're going to see is that everything that is running as Java is going to run in Azure, despite you're doing some calls into your DB2 if that's the scenario. So if your program is consuming DB2, yes, you're going against the DB2. You can also configure, because the DB2 is still in the mainframe, you can also configure the utilization of your SIP CPUs, and 60% of every transaction that you do on the DB2 is the generosity level that you have in the mainframe is going to be running in the SIP CPUs. So you'll save in every transaction that you execute in Java to the 100%. You'll save up to 60% into every DB2 transaction as well, and then the rest is going to remain on the GPPs, as you saw that 0.01 on my test, right, on my demo.
Right.
And we can come to those numbers. We can analyze that together with you as we're doing the POC, getting all together these results and helping you put together the business case. That's a part of the process that we follow with customers on the engagement.
Right.
And the last one was about JCLs. So I think I already mentioned we're not touching the JCLs. Now there's a possible scenario. There's a customer asking us, hey, I'm spending a lot of money into my sorts. I'm paying separately my sorts license. Can we substitute the sort for the one that you use in your Renovate solution? Eventually, yes, we have the need to develop some utilities for the JCLs to run outside of the mainframe into Renovate. We can use that code as well. We can use that logic that we created to reduce even more the costs of the Relocate operations. Not every customer is into that, but that could be another scenario. And like I said, let us analyze yours. Let us work together, take you through the best possible scenario in this journey.
Right. As a follow-up to the DB2 question, there was a question around what types of files are supported. VSAM.
Yes, we support VSAM and QSAM files, and obviously all the sequential files, including GDGs, all those files we support.
Okay.
The libraries that we produce, they manage the access and everything into those files.
Right, and you may have just touched on this, but I want to make sure that we cover it. There was a question around the communication between Azure and the local DB2 instance, how it's configured and how difficult it is to set up. That was the last kind of phrase in that question, is how difficult is it to set up that architectural change?
I love showing things. So yes, that's a great question. So it's a configuration that you basically do into the servers, and then where's the DB2 database parameters? So you just need to provide your JDBC adapter credentials and have the JDBC available to the interface. And that's it. It's just the URL and ready to run. With that, you can access the DB2. Obviously, the customer needs to provide their own JDBC and license, right?
Right.
But it's a very fast, very quick and easy configuration of the connection string.
Excuse me. And then obviously a question around performance as we get into the testing. I think we alluded to that there's a variety of different testing that takes place between, obviously the transformation and trying to demonstrate that it's functionally and data equivalent. Then we got to get into the other pieces of testing, including performance testing. And, there's a question around the performance difference between the mainframe and running exclusively in the mainframe environment and across Azure. We're working and have discussed different benchmarking around that performance, and taking Azure obviously as our target, but also into the zip and other targets, to ensure that we can demonstrate the performance there. I don't know that we've got exact numbers on the elapsed time or the differences there, but it's something that we're working to publish, and we'll be doing so soon.
And an experience, David, I've seen both. I've seen customers that they out of the box, they just get like 50% less elapsed time, and some others that they get 50% more elapsed time. It obviously varies, and the main factor that actually helps there, it's the logic that you're using. In Java, you're able to control prefetching, for example. We do that as part of the standard product. So we optimize the way we access the files. And that's the kind of things that and there's many other options that we have. You can configure also doing some caching. So for a specific, let's say, DB2 tables, or for specific information, you can even cache part of that optionally. So there are some techniques that we're using in Java that they are not present in COBOL, in particular in the old COBOL, that will really give you very, very good results.
Okay, so I think the answer around that is it's an architectural and configuration challenge there. It's something that be looked at on an individual basis. We can't predict what every environment's going to look like, but we do know from our experience, how those can be optimized and how you can get the most of the new type of configuration for that system. Okay, right. I think that's all the questions that we have that were asked live. I want to thank you, George, for taking us through that. I mean, it was incredibly fast. I looked up and we were 20-something minutes into the webinar, and we had already demonstrated that we were moving pretty quickly. So I want to make sure that we have a chance to follow up and get this recording out to everyone. So please, for all of you that attended, I want to thank you and also tell you that a recording of this will be posted on our website. You'll get an email from me with that link so that you can access it. I encourage you to share that with other members of your team that could be interested in this type of shifting of workload. We'll answer any questions that you have. I did have one question that snuck in here right at the end, and maybe we can answer it before we sign off for the day.
Why not? We're still on time.
Okay. And it is about cost savings, differences between CloudFrame on the Zip versus CloudFrame on Azure. And I'll take a swing at that real quickly, and then maybe George, you can come in and clean up whatever messes I get us into. But obviously, there are differences, and people have cloud deployments and cloud agreements with, say, Azure, where they've got capacity there that they're needing to use. And so this helps you take advantage of unused capacity that you might have into your Azure platform. In that case, it's kind of difficult to measure the difference between a Zip environment and Azure. If you're prepaying for the Azure instance, for instance, that would be difficult to measure. On the Zip side of it, obviously the workload that runs in the Zip is treated differently from GPP workloads. And so that also is something that is very hard to compare the two. It just depends on your particular environment. So when you get into that case, what we recommend that you do is schedule some time with our team. We, as George alluded to, we have a business case calculator that'll go through and ask some questions about your deployment, whether you're using a Zip or not, whether you've got prepaid Azure capacity that you need to use. And we'll try to figure out, the best way for you to present a business case for whatever direction that you would like to take there. We can do that standalone in either environment, or maybe we'll get to the numbers so that we can compare the difference, but each individual implementation is going to be a little bit different. Did I answer that correctly, George?
You did very well. Just to add a little thing, which is a real scenario, the fact that the business, the model is simple, that doesn't mean that it's very accurate, and it can basically comprehend many scenarios. One of the scenarios that I've seen is that there's countries in which the Zip CPUs are paid recurrently, which is not most of America's. So that are the kind of things that we have to put together in that business case, among others, because we want to consider your specific scenario as well. So
great. And then the longer we stay on, the more questions that we're getting popped in here. There was another about other cloud platforms. I'll answer that. Our presentation today was based on shifting compute to Azure. When we go through and use the cross compile function of Relocate, which is the CloudFrame product that does the cross compile, that generates Java bytecode, that Java bytecode can theoretically be deployed anywhere that there's a JVM. And so obviously the connectivity is important there and how that's configured, but for other cloud platforms, if we can say that answers your question. So, like I said, we've got a recording that will be published that will come directly from me. That'll notify you when it's available. If you have additional questions, please pop them in response, and I'll ensure that we get someone to answer those questions, or I'll follow up with you directly. Thank you very much, George, for taking us through this. Thank you, everyone, for staying with us for the entire length of the presentation today. I wish you a great day, and I look forward to seeing you next month on our Information and Inform webinar.
Thanks, David. Thanks, everybody.
All right, take care. Bye-bye.